Okay, the last one that we have here is going to be solving problems involving radioactive decay. These are going to be kind of some funky looking word problems. The nice thing about these is you don't have to worry about setting up an equation or anything because they are going to give you the equation. So they will all start out as the function a equals a sub 0. The way we say a sub 0 is a naught. Okay. So we've got a equals a naught e to the negative 0.00866x. So right there, they give us our equation. Okay, things we need to know, this a naught, which is again your a sub 0, that's your initial amount. So that's basically your start. Okay, then I've got my a. Okay, A is the amount of material after a certain number of years. So A is essentially my end value, which if we think back to our original equation, y equals A times B to the x power. Okay, A has always been our start. This Y has always been our end. So they've just switched what letters we're using here. So that's still our end. This is still our start value here. Okay, and then we have our X, which by now I hope that we know that our X value is referring to our time. Okay, so specifically years for this one up here. Okay, so the function a equals a naught e to the negative 0.00866x power models the amount in pounds of a particular radioactive material stored in a concrete vault, where X is the number of years since the material was put into the vault. Okay, so all this information up here is really just, hey, here's your formula. That's essentially all that information is saying. Now, the important part is coming up here next. It says if 200 pounds of the material are placed in the vault. So they put 200 pounds in the vault. That sounds like a start value to me. Okay, that's what they're putting in there. How much time will need to pass for only 59 pounds to remain? So we're trying to figure out how much is going to be left. Well, that would mean that 59 pounds would be my end value. Okay. Now, what are they asking for here? Well, they're asking for how much time. So we are going to be solving for that little X value up there. Okay. So I'm going to plug in my start and my end values. Okay. I've got 59 pounds is what I ended at. And that equals my start value is 200 times E. Okay, remember E is not a variable. That's 2.71 approximately. You got that button on your calculator for it. Negative 0.00866x. And we're going to be solving for that x. Our goal is to try and get that x by itself. So when I see that x, I see that it's up in the exponent. And I need to remember the only way I can get that thing down is I'm going to have to hit that with a log. But before I can hit that with a log, okay, I've got to get rid of this 200 that's in front of it. So my first step for this should be to divide both sides of this by 200. Okay, which I'm just going to leave that as 59 over 200 equals E to the negative 0.00866x. Okay, again, we're trying to get that x down. That x is up in the exponent. So how can I get that x down? Well, this is where I'm going to need to hit it with a log. What does the base of the log need to be if I'm using E there? Well, it needs to be a log base E, which remember log base E is your natural log. So I'm going to hit that with an ln. Okay, ln and E will cancel each other. I'm going to be left with a negative 0.00866x. Okay, if I hit it with a log on one side, though, I do have to hit it with a log on the other side as well. So I need to figure out what is ln of 59 over 200. So ln 59 over 200. Oops, put the parentheses in the wrong spot on my calculator. My bad. Gives me a, and I like to not round very much, negative 1.22078. Okay. Just put 5 digits there just because I felt like it. Okay. Again, trying to get the x by itself. So the only issue I have now is this number in front. So I would want to divide by that to get rid of that number. So I'm going to divide by negative 0.00866, which will cancel that. I've got to divide this side also by negative 0.00866. And when I do that, I end up with negative 1.22078 divided by negative 0.00866. I get 140.96, so I can round that up to 141 years. It's going to take 141 years for that radioactive material to only have 59 pounds be radioactive. Okay? So, quite a while. So again, just remember, x up in the exponent, we have to hit it with a log. Before I can hit it with that log, though, I got to get rid of the number in front. Then I can hit it with my log, and then it's just solving a normal equation. Okay, let's do one more. Function again. A equals A naught. Remember what your A naught is. Remember what your A is. E to the negative 0.00788x. So just kind of change that number up there. That's the amount of pounds of plutonium-238 that is stored in a concrete vault. Plutonium, pretty radioactive. Where X is the number of years since the material was put into the vault. When there is less than 1 pound of plutonium, it is no longer considered radioactive. So when there is less than 1 pound of plutonium, it's no longer considered radioactive. If, again, they put 200 pounds of the material placed into the vault, how much time will need to pass for it to no longer be radioactive? So they gave us our start value, 200 pounds again. And our end value, they didn't explicitly say this was our end value, but they want to know when it will no longer be radioactive. Well, that's going to be less than 1 pound. So our end value that we will use for this is just going to be 1 pound. Because anything past that time that we find for our answer here would be when it is less than 1 pound, which is when it would no longer be radioactive. Okay, so same thing here. Whoops. I'm going to put my start value in for the A. So again, 200 equals my start, gosh, I put that backwards. I'm sorry. I'm going to put my end value first. That A is my end value first. So I'm going to put the 1 equals my start value, which is 200, okay, times E to the negative 0.00788 X. Again, they're asking for time, how long, so we're solving for that X there. Just like before I can hit this with the log to get the X down, I've got to divide by 200 to get rid of that. So I've got 1 over 200 here. 1 over 200 equals E to the negative 0.00788 X. Now I'm ready to try and get that X down. How can I get that X down? Well, I'd want to hit it with a natural log. So ln, okay, allow those to cancel. I've got to do the same thing on this side as well. So while my ln and e have canceled, I'm left with 0.00788x. I need to figure out what is ln of 1 over 200. That gives me a negative 5.29832. Okay. Last thing, I've got to get this x by itself. Just divide by the number that's out in front of it. So dividing by negative 0.00788, which we get that to cancel. Do the same over here. This is going to be a big number. So negative 5.29832 divided by negative 0.00788. And I end up with 672.37, so 672.4 years. So long time before that is no longer going to be radioactive. Okay? And those are just some of our word problems. Basically, what I need you guys to remember for this, when the x is up here, the only way we can get that x down is hitting it with a log. Before I can hit it with a log, I got to get rid of the number that is in front of that e value.